Hello viewers, in today's session we are going to discuss another important problem from differentiability of functions. And here we have to discuss the differentiability of this function at x is equal to 2, and here the function f of x is defined as a piecewise function. F of x is equal to 2 plus x for all x less than or equal to 2, and here f of x is 6 minus x for all x greater than 2, right? So to discuss the differentiability of this function, we have to find out the right hand derivative and the left hand derivative, right? And we have to see whether the right hand derivative and the left hand derivative both exist and they are finite, and if both the derivatives are equal to each other, then we can claim that the function is differentiable at x is equal to 2. So we find the right hand derivative at x is equal to 2 and the left hand derivative at x is equal to 2, right? And if any of the derivative, that is right hand derivative or left hand derivative, it is not finite, then we can say that the given function is not differentiable at x is equal to 2. So let us find out the right hand derivative and left hand derivative for this function at x is equal to 2. So let us start with the right hand derivative. And the right hand derivative, the notation for right hand derivative may be taken as f prime. Here we write positive, and here we have 2, right? So we have limit h tends to 0, and we have f of 2 plus h minus f of 2 divided by h. Now here we have used the definition of right hand derivative as f prime. Here we have positive, and if we take some general point, say x is equal to a, then the right hand derivative is given by this limit, that is f of a plus h minus f of a divided by h. Now here our point a is given as 2, so we have limit h tends to 0 and f of 2 plus h. Here a is 2, so we have 2 plus h and then f of 2 divided by h, right? And here h is infinitesimally very small quantity, and it is a positive one, right? So h is a positive quantity and it is greater than 0 but less than 1, right? So let us evaluate this limit. So we have limit h tends to 0, f of 2 plus h. Now see, here we have a is equal to 2, and in the left neighborhood we have 2 minus h, and here we have 2 plus h, right? So all values of x which lies towards the right of a is equal to 2 are greater than 2. 2 plus h is greater than 2, and 2 minus h is less than 2, right? So to get the value of f of 2 plus h, will use this part of the function, that is 6 minus x, because x is greater than 2, and here x is 2 plus h, and 2 plus h is greater than 2 because h is a positive quantity. So 2 plus h is greater than 2. So we have 6 minus, here x can be replaced by 2 plus h, and then we have here f of 2. So to get the value of f of 2, will make use of this part of the function, that is f of x is 2 plus x for x equal to 2, right? So f of 2 can be obtained from here. So we have 2 plus 2, because we can take x is equal to 2, and here in the denominator we have h. Now let us simplify it. So we have limit h tends to 0, we have 6 minus 2 minus h, and here we have minus 4, and here we have h. So we have limit h tends to 0, and 6 minus 2 is 4, and 4 minus 4 is 0. So we left with minus h over h. So h and h get cancelled, so we have limit h tends to 0 minus 1. So here this term is independent of h, so this limit is equal to minus 1. So we see that the right hand derivative is equal to minus 1 at this point, that is x is equal to 2. Now let us calculate the left hand derivative. So the left hand derivative, the notation may be written as here f prime, here we can take the negative sign, and here we have a. So this is given by limit h tends to 0 f of a minus h minus f of a divided by minus h. Now the left hand derivative is given by f prime minus, here we have 2, and this is limit h tends to 0 f of a minus h. So a is our 2, and here we have 2 minus h, then f of 2, and here we have minus h. Now we can write limit h tends to 0 and f of 2 minus h. Now see, 2 minus h is less than 2, right? So when we have x less than 2, then f of x is equal to 2 plus x. So we'll now use this form of the function for f of 2 minus h. So we have 2 plus 2 minus h, taking x is equal to 2 minus h over here, because x is less than 2, because f of x is defined as 2 plus x for all x less than or equal to 2. And now f of 2 is given by 2 plus 2, and here we have minus h. Now see, this is the limit h tends to 0, this is 4 minus h, and here we have 2 plus 2 is equal to 4, and here we have minus h. And now this 4 and this 4 get cancelled. We are left with limit h tends to 0 minus h over minus h, and minus get cancelled, h and h get cancelled, so we are left with limit h tends to 0 and 1, and this term is independent of h, so this limit is simply equal to 1. So we can see that the left hand derivative is positive 1. Now from this discussion we have seen that the right hand derivative and left hand derivative both exist, and they are finite, because right hand derivative is minus 1, left hand derivative is plus 1. But the condition for differentiability is right hand derivative should be equal to left hand derivative, right? But here the right hand derivative is not equal to left hand derivative, because minus 1 is not equal to plus 1. So we can say that although the right hand derivative and left hand derivative, they exist and they are finite, but they are not equal to each other. So this function is not differentiable at x is equal to 2. So this is how we can discuss, or we can check the differentiability of functions of this type at a given point.